Hello my dear students. In the previous class we have studied about some of the things related to bridge circuit. In that we have studied the different types of bridge circuit such as AC bridge circuit and DC bridge circuit. And also we have studied some of the examples related to AC and DC bridge circuit. Now in the today's class we are going to study the example of DC bridge circuit, that is Wheatstone bridge circuit. In this class we are going to study the construction and operation of Wheatstone bridge circuit and some of the derivation related to Wheatstone bridge, and at the end of the class we are going to study the advantage, disadvantage, application and some of the limitations related to Wheatstone bridge circuit. Now let us begin with our topic. Wheatstone bridge is the simplest form of DC bridge which is used for the purpose of measuring the value of unknown resistance. Here, Wheatstone bridge is one of the best example for DC bridge circuit, which is used for determining only the value of unknown resistance. Here, as you know, the unknown resistance value is measured in ohm. Wheatstone bridge is widely used for precision measurement of resistance approximately from 1 ohm to 10 mega ohms. It is the most accurate method available for measuring resistance in different laboratories. Now let us try to understand the basic operations of Wheatstone bridge. Look at the circuit diagram of Wheatstone bridge circuit. Here you can see there are 4 resistor elements are being used. These 4 resistor elements are interconnected with 4 junctions, that is A, B, C and D. Here R1 and R2 resistors are called as fixed resistor. R3 resistor is called as adjustable resistor, and R4 resistor is also called as RX resistor, and it is denoted as unknown resistor. Here you can see the 4 resistor R1, R2, R3 and R4 are interconnected with junction A, B, C and D in such a way that it forms 4 different arms such as ratio arm, standard arm and unknown arm. Here you can observe that as an input voltage, EMF DC voltage source is applied and which is directly connected to the opposite 2 junction, that is A and B. Similarly, here null detector or galvanometer is connected to other 2 junctions C and D. In the Wheatstone bridge circuit, the null detector and galvanometer is used to check whether the circuit is under balance condition or not. Now I would like to tell you what do you mean by the balance condition in the bridge circuit. Here, before applying any DC voltage, the pointer which you can see on the screen has to always display the 0 volt. That means the pointer has to point towards 0th position. If it is not, then we can say the bridge is not under the balanced condition, but it is unbalanced condition. To make the bridge under balanced condition, the flow of current through the galvanometer has to be 0. In the Wheatstone bridge circuit, the current flowing through the galvanometer is depend on potential difference between the point C and D. The bridge is said to be under the balance condition when the potential difference across the galvanometer is 0 volt, so that there is no current flowing through the galvanometer. Hence, the bridge is under the balance condition. When the potential difference between C and D are equal, then the voltage across two ratio arm, such as the voltage across R1, that is voltage V1, and the voltage across R2, that is V2, are same. If the voltage across R1 and R2 are same, then we can write here that V1 is equal to V2. Consider this as equation number 1. According to Ohm's law, V is equal to I into R, so that above equation number 1 becomes I1 into R1 is equal to I2 into R2. Consider this as equation number 2. When the current flowing through the galvanometer is 0, then the following condition should be satisfied. That means here the flow of current through the resistor R1 and the flow of current through the resistor R3 has to same. If the flow of current flowing through the resistor R1, that is I1, and the flow of current flowing through the resistor R3, that is I3, are same, then we can write here that I1 is equal to I3. According to Ohm's law, if the flow of current flowing through the resistor R1 and I3 are same, then the flow of current flowing through the resistor R1 and R3 is equal to the voltage applied in the circuit, that is E divided by total resistance R1 plus R3. So that here we can write I1 is equal to I3, that is equal to E divided by R1 plus R3. Consider this as equation number 2. Similarly, if the flow of current flowing through the resistor R2 and the flow of current flowing through the resistor R4 are equal, then we can write I2 is equal to I4. According to Ohm's law, the flow of current flowing through the resistor R2 and R4 is equal to voltage applied across the circuit divided by total resistance, that is R2 plus R4. So that we can write the equation as E divided by R2 plus R4. Consider this as equation number 3. Substitute the value of I1 and I2 in equation number 1, so that equation number 1 becomes E divided by R1 plus R3 into R1, that is equal to E divided by R2 plus R4 into R2. Consider this as equation number 4. Now you can see here, if I cancel out E in the equation, we can rewritten this equation as R1 divided by R1 plus R3 is equal to R2 divided by R2 plus R4. Consider this as equation number 5. Now take R1 plus R3 at the right hand side and take R2 plus R4 term at the left hand side, so that here I can rewritten the equation as R1 into R2 plus R4 is equal to R2 into R1 plus R3. Consider this as equation number 6. Now multiply the term R1 and R2, so that equation becomes R1 into R2 plus R1 into R4 is equal to R1 into R2 plus R2 into R3. Consider this as equation number 7. Now just observe the equation number 7. In that common term is R1 into R2. So that cancel out R1 and R2 in the equation number 7. So that we can rewrite the equation as R1 into R4 is equal to R2 into R3. Consider this as equation number 8. The above equation is called as the balanced equation for Wheatstone bridge. Since R4 is unknown resistor, then R4 becomes R4 is equal to R2 into R3 divided by R1. Consider this as equation number 9. We know that in the circuit diagram of Wheatstone bridge, R4 is equal to Rx. So that the equation number 9 becomes Rx is equal to R2 into R3 divided by R1, where Rx is equal to unknown resistance, R1 and R2 is equal to fixed resistance, and R3 is equal to adjustable resistance. Now, to find any problem related to Wheatstone bridge, this equation is very important. That is, Rx is equal to R2 into R3 divided by R1. And here we can say that the balanced equation for Wheatstone bridge is R1 into R4 is equal to R2 into R3. So these two equations are very important to solve any problem related to Wheatstone bridge. Now, let us see the advantages or merits of Wheatstone bridge. First point is, it can be used to measure the value of unknown resistance. Wheatstone bridge can give accurate readings under the balanced condition. And last one is, Wheatstone bridge is more reliable than other type of DC bridge. These are the three advantages of Wheatstone bridge. Now look at the disadvantages or demerits of Wheatstone bridge. Wheatstone bridge gives inaccurate readings if it is unbalanced. That means before applying any input voltage, if the galvanometer shows some reading, then it is called as the bridge is not under the balance condition. In that case, it will provide an error. Next point is, it is not susceptible to high DC current. That means the Wheatstone bridge circuit is not sustainable to high DC current. If high DC current is flowing in the circuit may get damaged. Now look at some of the applications of Wheatstone bridge. Here, Wheatstone bridge circuit is used by the telephone companies and others to locate the cable faults. It is used for the measurement of the resistance of the transformer winding, such as primary and secondary winding, or to measure the resistance of motor winding as well. This bridge is used in many electronic applications to measure change in resistance depending on the pressure applied, such as strain gauge transducer. Now at last we will see some of the limitations of Wheatstone bridge. The first point is insufficient sensitivity of the null detector. That means here in the Wheatstone bridge circuit, null detector is not that much sensitive than other types of DC bridge circuit. And here, change in resistance value of the bridge arms due to heating effect of the current to the resistor. That means due to the heating effect, here the value of the resistor may get changed and provide wrong reading. These are the two limitations of Wheatstone bridge. This is what end of the presentation. In the next class, we will try to solve some of the problems related to Wheatstone bridge circuit. Thank you and see you in the next video.